Welcome to part 2 of the work solution for question 10 from the November 2014 Time Zone 1 paper 2. Okay, in this part we've been asked to write down the standardised value for 815 grams. Another word for this, another term that we use for standardised value is the Z score. Okay, and then we've been asked to find sigma. Now sigma represents the standard deviation. So let's go green flavour for now. Okay, now it says write down standardised value. Okay, so we should be able to find it somewhere. We don't have to do any working out. We just have to be able to find it and write it down. Now this is a paper 2, so we've got to sort of assume that they want us to use some form of technology, being our GDC. All right. Now, with the information that we've got, we know that we don't have a standard deviation. We've got an area, all right, and we've got 2 points, right, and we know what the mean is. Okay, so let's pull out our GDC. All right, now we're talking about normal distribution, so that's in statistics, so we're going to go press 2 for normal distribution. We'll go to distribution, 2 for statistics, sorry, distribution. We're going to F1 normal distribution, and because we've got the area underneath the curve, we're going to be looking at the inverse, okay, inverse normal distribution. So we'll press that here. Okay, now as far as our data is going to be variable, all right, and with what we know, we could do this 2 ways. Okay, we could include the area. We know what the area is from 815 all the way to the lower end over here, but we also know the area just between these 2 points here. So let's just use that. So we know the area is 78.87 between 705 and 815. So we're not having a tail here. We're looking at the centre or central. And our area in decimal is 0.7887. Okay, that's our area. All right, we're going to leave our standard deviation there at 1. And our mean, which we know, is 760. Okay, whoop. 760. Execute. Let's see how we go. Okay, now this has given us the Z score for both these regions here. So it's given us the Z score for 705 and it's given us the Z score for 815. Okay, because these are equal distances away from the mean. So our Z score, let's just go back that and have a look. Our Z score is going to be whatever this is above the mean. So this is 761.2499, okay? Or let's round that up to 3 significant figures. That's going to be 1.25. So our Z score is approximate to 1.25. So our Z is approximate to 1.25. And we use the technology to find it. So all we had to do was write it down. We didn't have to show any working. Hence, or otherwise, find sigma, or the standard deviation. Now we have to do some working. And this is where you might want to consult your formula booklet. Now, if you open up your formula booklet to the to the 5th page, and at the bottom you can see the standardised normal variable, and it tells us that Z is equal to our position minus the mean over our standard deviation. Okay, now we have our Z score. We know that Z score comes from the position of 815 grams, and we know what the mean is. So we just have to rearrange this formula, this equation, to solve for sigma. So what I'm going to do is I'm going to multiply both sides by sigma to get this out of the fraction, so that would be sigma multiplied by z, all right? And then I'm going to get rid of the z by dividing sigma. So if we're going to rearrange it, sigma is sigma, that's q. Let's go back. Sigma will be equal to x minus the mean over our z-score. So let's just substitute our values in there. We know that this is the z-score of 815 minus the mean, which is 760, divided by our z-score, which is approximate to 1.25, right there. Now, if we use our calculator to figure that out, we'll realise then, let's just bring this down a touch, that our standard deviation is equal to exactly 44. Okay, now if you need any clarification on any part of this work solution, please comment below and I will do that for you. And I'll see you in the next video where we'll be doing parts C, D and E. Okay, see you in the next video.